Now we are given r plus 2s equal a and r minus 2s equal b, and we are supposed to prove that r times s is equal to a squared minus b squared over 8. This is minus here. It's not a plus, it's a minus. So say you have an example, and in this example they say t is equals to 3 and u is equals to 2, and they want you to prove that tu is equals to 6. So basically they're saying t multiplied by u is equal to 3 multiplied by 2. So tu, 3 times 2 will be 6. That's the approach that we are using here today. So given this equation, the best option would be first to simplify the equation. Make r subject of the formula, make r again subject of the formula, equate the two. Then once you've created the two, you can try to simplify from there. Eventually you should have r and you should have s. Then you should multiply them together to get a squared minus b squared over 8. So let us try. So here we see that r is equal to a. 2s will cross the equal sign and become negative 2s. This is your first part. Then your second part would be that r is equal to b plus, because this will go to the other side, become positive. So plus 2s, right? We see this is r and this is r, so we can equate r together and say that a minus 2s is equal to b plus 2s. This is valid because r is the same value throughout. And simplifying this, you have that you can take 2 to the other side and b to this side. So a minus b is equals to 4s, because 2 plus 2 is equal to 4. So s is equals to a minus b over 2. Okay, yes. So now that we have s, we should find r in terms of a and b. This is s. Okay, sorry, this should be a 4. So we have to find r in terms of a and b. We have s in terms of a and b. From this, we know that s remains constant throughout. So wherever there is s, we can substitute this value. And where there is s is here or here. You can choose. So I'm going to choose the second one. So that I work with positive values. So r is equal to b plus, where there is s, we substitute a, you substitute s. So you're going to substitute a minus b over 4. Okay. Then we'll simplify that. You will find that b plus 2 into a minus b over So R is equal to B plus 2A minus 2B over 4. Simplifying it further, B plus, so here you can see that you have 2A minus 2B over 4. So you multiply this by 4. So you have that. Okay. Remember, if you have, say for example, you have 1 over 2 plus 3, and you want to simplify that, you should multiply, the common denominator is 2. So in order to have 3, you multiply 2 and 3, you have 6. So 6 over 2 would give you 3. So in order to have 3, you will need 6 divided by 2, and this will be 1. So simplifying this will ultimately give you 7 over 2. 7 over 2 is 3.5. So 3.5. Simple. And then now you can simplify this. This is 4b and this is 2b. 4b minus 2b is 2b plus 2a over 4. Then you can simplify this because you have a common value here. So b, take out 2 as a common factor, b plus a over 4. So this will cancel this, and you will be left with b plus a over 2. So this is your R, and this is your S. To solve R times S, or S times R, you see, you are going to have A minus B over 4 multiplied by B plus A over 2. And this is your SR. So you simplify this. If you rearrange A, you just rearrange because they are both positive, but you cannot rearrange if there is a negative here, because if you take this to the other side, you'll have positive A. So you can't just rearrange whenever, but if it's both positive values, you can rearrange them without a problem. See, now you multiply this with this. So since it is multiplying and they're both brackets, you can just multiply. Looking at these, minus b, you can see that they are the difference of 2 squares, and 4 multiplied by 2. Well, the difference of 2 squares means that a times a will be a squared, then a times b will be ab, negative b times a will be negative ab. So negative ab and positive ab will cancel out. Then you have b times b, which is b squared over 8. So this is your proof that SR is equals to a squared minus b squared over